Hello, we're going to be doing a little demo here of some of the features of the TCM-U2 hardness tester. I'm going to try and keep it in this little envelope here to work with, and really this little presentation is more for our customers who have the device. Nobody likes to read a manual, and so we're going to just show you many of the features of the devices that you're an owner, so you don't have to go through the manual and understand all of the features of the product. So the very first thing is, this is one of the UCI probes. With the device itself, this whole thing is under $2,000, and our closest competitor is around $5,000, and they don't offer the same feature set that we do, including the fact that we can add a D-type probe for doing leab or rebound type testing, which is a whole different sort of technology. You can get that as an option for this device. We also include the software to communicate to a PC and the cable to plug into the USB port on top of the device. The batteries are rechargeable. We include the charger, of course, and if I just take the little silicone rubber bumper off the outside, you can see here are the batteries. We're using rechargeable in this case. You can just use your regular alkaline also. So let's pop that back on again. So another thing with the tester is that we include the foot. And this foot here can be screwed off. You can see, so we go back to the probe itself, its shroud. Here is the little Vickers diamond tip, and this is on a very high frequency vibrating rod that's inside the device, of course. So you can actually freehand it right like this, always with two hands so you keep it stable. Or we include the foot, and the foot here is flat on the bottom, as you can see, so very easy for doing quick tests on flat parts. Or you can screw the end off, and you can see here we have a large V-groove and a small V-groove, so for larger diameter OD parts and for smaller diameter OD parts. I'll just put this back on again. Alright, so when we turn the device on, it will go straight into measurement mode, as you can see here. Because primarily when you're using the device, you're going to be doing tests. So if I go and do a quick test on this calibration block here, you can see here is a value, 42.5, moving over, 42.5, pretty repeatable. So if I now want to go out and actually change some settings or look at some of the other things inside the device, for example, info screen or archiving, I could hit the power button here, scroll down to exit to leave this mode, and now I can go to the measure screen, information, and so on other screens, or go back to measurement, hitting the button again here to select, and I've now gone back into measurement. If I have the device powered off, and you should never unplug the probe whilst it's connected. The reason is that we actually have our own memory inside of the probe. The advantage of this is very significant in that we can have multiple different probes plugged into a device, because all the calibrations are stored with the probe. The device itself doesn't matter. So you could have 3 testers and 8 probes, and they are all interchangeable. Now, because it's volatile memory like that, if you unplug and plug it back in again, it's like removing a SIM card from a phone, for example, whilst it's powered on. There's a very good chance you're going to wipe the memory. In this case, you're going to wipe out the calibration settings, and you'd have to recreate them. So if I power on now, you will see the device will go into the mode where I can scroll through the menu. It doesn't go straight into measuring, all right? And the reason is that obviously I can't measure because there is no probe attached. I cannot go into the calibration settings. If I try to select, it won't do it, because again there is no probe attached. So just power off again, plug it back into the device, and let's power on. Okay, so doing testing. I'm just going to work on this block here because it's simple, but we could do testing of parts like this, or this, or these sort of things. I show in another video the testing of a tap like this, where the face of the tap, or the actual tap area, has been hardened just in this area, because you don't want to have it all hardened, it'd be way too brittle. So the tang, or the body of the tap here, is softer. This is soft too. This is hard, and you can even measure in this area here. But I'll just show you that if, when I'm doing a test, I push down, and it's a two-step process. So the first thing is the spring on the foot, it's taking up its load, and then once that is done, and then the tip is exposed, and we go deep enough, you can see here a secondary load which is pushing the rod with the diamond tip up inside of the probe. So when I press down, you'll see the icon will move on the screen. That means contact is made, and it's trying to do a test. All that's happened is the loop through the device has been closed. But because I haven't applied the correct load, in this case it's a 50 N probe, or approximately 12.5 pounds, 50 N is 50 newtons, it's got to take up that secondary load. So if I just go back in here and I hit select, and I'm going to delete this setting, it takes you back to the root, and I do it correctly, I press down, and there's the secondary load, press down, spring, secondary load, you can see it's very, very repeatable. What I'm showing on the display here is actually each test, but if I want to go in and I want to see what the statistics are for this, I can go into statistics mode, and I can select it, and here you can see I have the maximum, which was 43.6, the minimum, which was the smallest value in the test, 42.8, the deviation was 1.2 HRC, the device is accurate to plus or minus 1.5, so we're well inside of that, and the average is 43.2. The more tests that you do, of course, the more it's going to average, and you're going to get closer to the actual result. So if I go back in here, I click select again, and I go back up here to normal, and I select it, I've gone back into this mode. If I hit select here and I want to delete all of those settings, I can do so, and I've gone right back to start again. So what I'm going to do now, I'm going to actually set up for doing what we call smart. And what smart does is that if I have an extraneous test, it will automatically reject that. So if I go ahead and I do 3 tests, the first one, you will see here that the test value itself is showing without being filled in, so it's 42.1, and just the outside boundary is showing. Let's just do another test. 42.5, and when I've done the third, the device says, okay, if I've got 3 tests, I can then do an average, and I can say if they're all within a tolerance, then accept that. And you'll see now, if I do the third one, that the display is filled in, so it's saying it's 42 as the average of all the tests. Now if I pick up a part that I know is considerably softer, like this, and I do a test on it, there's the value, it's automatically rejected by the system. It's thrown out because it knows that it's outside of a tolerance. So how do we go and look at that tolerance? If I go back into select, and I'm going to go and exit out of this, I'm going to go back into here, which is the settings screen. I hit select, and I'm doing the settings here for the probe, and this will be for the device, and I can scroll between those two, as you can see. Okay, so the tolerance here at 7% is saying if each test subsequently is outside that tolerance range of 7%, it will automatically delete it. So that's what that is. The other one up here is whilst doing a test, my preference is always to show what the current value is, what the actual test value was, but we can set this up to do, is to constantly show the average. So every time you do a test, it's going to average the ones before and show that on the display. I'm just going to leave it on current. I'll describe what retro is in another demonstration. So hit the back key. If I scroll across now to device, we've also got settings here for English, other languages as well, of course. The brightness of the display, that's what we've got turned on now with the backlight turned on. And the sound here is if I want to have it beep every time I hit a key press, I've got it for that, and also when doing a test it's going to beep. I like that audible feedback. But if you don't, you can always change it so that it only does a beep when you're doing a measure, for example. So now if I use the cursor control keys, the control keys or any key, there is no beep sound anymore. If I want to, I can turn off all the sounds so it never does it. Anyway, you get what the point is. Here I'm going to leave it so it's key and measure, so every time I move about it's going to beep. And when I do a measurement it's going to beep as well. Auto off is to save the batteries. Like many devices, you want to have a timeout set where after a certain period of time the device will switch off if you happen to leave it on by mistake on a desk or wherever, that you're not just going to drain the batteries to dead. So we can set this up here for 1 minute, 5, 10 or 30. Or because I'm doing this demonstration, I'm going to leave it as being off. Hit the back key here. Other settings through this display are archive. So we can look at all the prior tests, and I do have some inside the system, so you can see here these are the prior tests I've done, right, with each of the values and the average, what the material is and what the scale is. These are all uploadable to a PC, and we have a special program for that where you can even then further upload to a spreadsheet and modify the data. And we include the software and the cable to do that. Moving along, calibration. I'm showing in a separate video, but just quickly if we go into that, this is the calibration screen. Back out. Measuring we've already looked at. Information is information about CIMETRIX. This is the company here, so if you don't have to worry about going to the web or anywhere else, you can just look right on the screen to contact us. And then it shows the serial number of the device and the probe. Of course, that will change the probe depending which one you have plugged in. We know what the firmware version is, 4.9. And the number of measurements. A good thing with this is that you can go to this mode if there are multiple users or over a period of time to say, hey, we've done 1,000 tests, we really should recalibrate. You can look at it right on that screen. So just go back. Memory card, as I had said, the device itself has its own memory, but if we want to copy from the device back to here to store it for archival reasons, or perhaps we're going to do a recalibration and we then make a mistake, we can always recall from here back to here and vice versa. So if I go into this, you can see I can create a backup copies of all the calibration. I can check the memory state of the little card that's inside. I can clear it, and I can load the backups back from here back to the device if I make a mistake and don't calibrate correctly. So there is a little bit about the device and how it works. If you have any questions, you can certainly call us at CIMETRIX Ltd. The number is 206-340-5995. Thank you for watching the video.